Hey, hello there. Let's talk about today's Leetcoding challenge question. Remove linked list elements. Given a linked list, we want to remove the nodes of a given value. Looking at the first example, we have a linked list of 7 nodes and we want to remove those nodes with value 6. That is to say, if we examine this input linked list, for every node we check its value. If its value is not 6, we will definitely keep it in the outputting linked list. And after that, we want to make sure the next pointer for this node is pointing to a node that's not 6. So if we're looking at the node 2 here, the next pointer is pointing to a node of value 6. So we want to short it, and we want to find the first node of whose value is not 6 in the subsequent linked list. We can use another pointer to find this and make sure that node 2 is actually pointing to that. So it's very clear that we can solve this by 2 pointers. So let's just demonstrate what the two pointers rows are. One of the pointer is pointing to the previous node that has value that's not 6. Then the next pointer should the job for this next pointer is to find the first node that's not this given value in the subsequent linked list. And once we find those two, the operation we do is to make sure that these two are connected together. That is to rewire this link. So node 2 will no longer point to node with value 6, but rather pointing to this first node in the subsequent linked list that has a value that's not 6. So that's pretty much the 2 pointer. And one special case is that if the linked list starts with this node value that we want to delete, then we should use a sentinel node for this purpose. So the previous starts with the sentinel. So the next pointer will identify the first node in the linked list that's not the value that we want to delete, and establish a link like this. As a result, in the return statement, we want to return the node that this sentinel node is pointing to. So that's the idea. So we initialize a sentinel node. The value doesn't really matter, and the next pointer should point to head in the beginning. In the beginning, it should point to the given head node. And the previous is initially pointing at the sentinel, and the next node is initially pointing at head. And we're just gonna do keep traversing until this next pointer is pointing at is no longer a valid node. That means the we will terminate while this next pointer is pointing. It's a null pointer. So every iteration, the job for the next pointer is to identify the first subsequent node that's not of this given value. So if the node is a node that we want to delete, we will advance it. So after this while loop, we should position the next node into the next pointer pointing at the first subsequent node that's of a value that we don't want to delete. That's the time we want to rewire this. So just comment this step here. After that, we want to move those two or move them forward. The situation here is that we could potentially have this next pointer pointing to a null pointer. In that case, we don't want to advance it. Otherwise, we will also move it forward as well. So let's say that we rewire the 2 pointing to 3. We want to move previous to 3, and we want to move the next to 4. So that in the next iteration, we will still try to find the next possible node from this new location. In the end, we return the node that the sentinel is pointing at. Yeah, so that's the code for this problem. In terms of time and space complexity, even though it looks like a nested loop, it's a linear time because the next is just moving to the next position, next position. So in total, it would just examine all the nodes inside this linked list exactly once. So it's a linear time. And for time complexity, all we have is a few pointers. So that's constant space. Yeah.